And here is the homework 2 of the class probability. Here is the problem 2, and we can solve this problem. Firstly, let's read the problem. Given the possibility of x1 equals to 0 is equals to 0.2, and the possibility of x1 equals to 1 is 0.8, and for all 1 less or equals to k less or equals to n. And we know that the possibility of x k plus 1 equals to 0 condition x k equals to 0 equals to 0.6, and the possibility of x k plus 1 equals to 1 condition x k equals to 0 is 0.4, and the possibility of x k plus 1 equals to 0 condition x k equals to 1 is 0.3, and the possibility of x k plus 1 equals to 1 condition x k equals to 1 is 0.7. And the first problem is, and the problem 8 is to find the possibility to find the possibility of x2 equal to 1. And before that, let's get something from the problem. We can know that the possibility of x2 equals to 1 is the possibility of x2 equal to 1 when x1 equals to 0, and p x1 equals to 0 plus the possibility of x2 equals to 1 condition x1 equals to 1, p the possibility of x1 equals to 1. And let's calculate this. It's 1 0. 1 0 is from the problem. We can know that 1 0 is 0.4. 0.4 multiplied the possibility of x1 is 0 is 0.2 plus 1 is 0.7 multiply 0.8, so it's 0.64. We can also know that the possibility of x2 equals to 0 is the possibility of x2 equal to 0 when x1 equals to 0 multiply x1 equal to 0 and plus the possibility of x2 equals to 0 when x1 equals to 0 multiply the possibility of x1 equal to 1, and it's 0 0 is 0.6 multiply 0.2 plus 0.1 is 0.3 multiply 0.2 0.8. So we can also write it as possibility x2 equal to 0, possibility x2 equal to 1 is equals to 0.2, 0.8, multiply the matrix of 0.6, 0.4, 0.3, 0.7, and equals to 0.36 and 0.64. So we have solved the problem A, that we know that the probability of x2 equals 1 is this 0.64. Yes, that's it. And the problem B is to find the possibility of x3 equals to 1. So we can calculate as the possibility of x3 equal to 0, possibility of x3 equal to 1 is we can write it as 0.2, 0.8, multiply the matrix 0.6, 0.4, 0.3, 0.7 to the 2. So the output is 0.408, 0.592. Yes, because from 1 to 3 we used 2 the matrix, so the output is like this. So we know that the probability of x3 equal to 1 is 0.592. So the problem B is solved. And let's take a look at the problem C. Find the possibility of x1 equal to 0 when x3 equals to 1. Let's solve this one problem. So now we get that the possibility of x3 equals to 0 and the possibility of x3 equals to 1. So if we calculate the possibility of x1 equal to 0 when x3 equals to 1, according to the Bayes theorem, we know that it's equal to the possibility of x1 equals to 0 and x3 equals to 1 divided by the possibility of x3 equals to 1. We can write it as the possibility of x3 equals to 1 condition x1 equal to 0 multiply possibility of x1 equal to 0 divided by possibility of x3 equals to 1. So the possibility of x3 equal to 1 condition x1 equals to 0 is we can calculate its its matrix to 12 to twos equals to 0.48, 0.52, 0.39, 0.61. So from the matrix, we know that the possibility of one zero is 0.48. So multiply the possibility of x1 is 0 is 0.2. Oh no. 0, 1. 1 0 is 0.52. Multiply 0.2 and divided by the possibility of x3 equals to 1. We know that x3 equals 1 is 0.592. Yeah, so we know we can calculate the output is roughly equals to 0.176. So we have solved the problem C. Let's read the problem D. To find the possibility of xn equals to 0 when n is infinite. Okay, let's solve the problem D. So we can calculate that the possibility of x infinite equals to 0, the possibility of x infinite equals to 1, it equals to when n is infinite 0.2, 0.8, multiply the matrix of 0.6, 0.4, 0.3, 0.7 to the nth. So we can calculate it, and the output is 0.2, 0.8, multiply the matrix of 3 to 7, 4 to 7, 3 divided by 7, 4 divided by 7. So we want to know the possibility of xn equal to 0. So it's the output is 3 divided by 7 and 4 divided by 7, and this one is the xn equal to 0, and this one is the xn equal to 1. So we know the output is 3 divided by 7. So the output is this is the output. That's all the problem 2 and answer, and that's all. Thank you.